this is the last note sheet before you start reviewing for a quiz. So, last note sheet, and then you'll have a review, and then you'll have a quiz. I need to change your quiz date. What? No, I didn't give you a review yet.
Before Tuesday.
So if you don't have school tomorrow, then you'll review on Thursday and your quiz will be on Friday. Okay? If I don't know that yet.
He told us.
Are you gonna give us that a few days? We can start on it tomorrow if we don't.
We're gonna have our tests Friday, guys. You don't gotta rush.
I mean, your quiz will still be on Friday. The review's not really long. I can. Shh. Hey. Stop talking.
Wow.
I can try and have some printed by the end of the day, so if you want to grab them before you leave. I do have an assistant that could print them off. I'd have to send it to her then.
Just spend like 30 seconds. Where?
Okay, well I have to get through this first. Alright. Shh. Hey, we're going to get started now. So, statisticians use measures of position to describe where specific values fall within a data set. Quartiles are 3 position measures that divide a data set arranged in ascending order into 4 groups. So if your data set is not in ascending order, you do need to put it in order from least to greatest. So it has to be in ascending order. Each of these pieces contain about 25% of the data. The median marks the second quartile. Okay, so your median here, we know how to find the median. It's in the second quartile there. And separates the data into upper and lower halves. The first or lower quartile, Q1, is the median or of the lower half. While the third or upper quartile, Q3, is the median of the upper half. Okay? So to find each quartile, you need to first find the median of the entire data set, so the middle term. Okay? Then you need to find a median of that lower half, so from your least one to your median, to find the lower quartile, and find the median between quartile 2 to the max value to get quartile 3. Okay, and then each piece is 25% of the data there. The 3 quartiles, along with the minimum and maximum values, are called a 5-number summary of a data set. Okay, so we're finding the 5-number summary. The difference between quartile 3 and quartile 1 is called the interquartile range, or IQR. The interquartile range contains about 50% of the values. Before deciding on which measures best describe a data set, check the data set for outliers. An outlier is an extremely high or extremely low value when compared with the rest of the values in the data set. To check for outliers, look for data values that are beyond the upper or lower quartiles by more than 1.5 times the interquartile range. Okay, so to find your outliers, what you're going to do, you're going to take your lower quartile, which is Q1, and you'll subtract 1.5 times the interquartile range. Okay, and that number that you get, if you have values lower than that number, it will be an outlier. Okay? To get your upper outlier, you'll take your third quartile and add on 1.5 times the interquartile range. Okay, and then when you get that number, if you have a value in your data set that is greater than that number, it will be an outlier. Okay, so we do have an example here below. And yes, I know it's not in ascending order, so we're going to have to put it in ascending order to do this. So to find a 5-number summary of the data set, I already have it in order for you here, so it does start with 2 as your minimum value. Okay, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12 fives. There are 12 fives. 12 fives. 12 fives. Okay, then there are 5 sixes. Okay, 5 sixes. 5 sevens. Hey, at least I'm writing it in order for you right now.
How many? 5, 7?
Yep. 1 8, 1 10, and 1 12. Okay, so you do need to write it in ascending order. Next, what you want to do is find the median of this data set, so the middlemost term. Okay, so you just want to go down each number.
It's 5 and 6.
It is between 5 and 6.
Yeah, 6, 5 and 6.
Okay, so in between 5 and 6 is your median. It is 5.5. And that is quartile 2. Okay, then to find quartile 1, we need to find the median in our lower half here. Okay, it is just going to be 5. That's quartile 1. We want to do the same thing for that upper half. So find the median of the upper half there. That'll be 7. And that'll be quartile 3. Then your last two, you need your minimum, which is your lowest value here. And your maximum value, which is your highest value. Five-number summary. 1, 2, 3, 4, 5. Okay, so the next step after you find your 5-number summary, you want to interpret that 5-number summary. So you just want to include a couple things given your different quartiles. So again, remembering each quartile is 25% of the data. So I can start with the minimum. So I can say the least amount of time taken was 2 minutes. And this is all times for an obstacle course of 26 students. Okay, so the least amount of time taken was 2 minutes. And the most amount of time was 12 minutes. Okay, then I want to say something about your different quartiles here. So I can say about 50% of the class completed the course in 5 minutes or less. So I was just using quartile 2 or that median. From that median, you can say about 50%, which is this lower half, finished the course in 5 minutes or less. And then I'm just going to say something about the upper part. So I'm going to take quartile 3. So if I go from quartile 3 and beyond, that's 25% of the class. So I can say about 25% of the class completed the course in 7 minutes or more. So all I did was include the minimum and the maximum times it took. I said something about the median, so I can say 50% of the class completed it from that median and then less. And then I did from quartile 3 and beyond, so about 25% of the class completed the course in 7 or more minutes. Okay, so you just have to interpret what each of those different percentages would be. The next part I want to do with this data set is to identify any outliers. So to do that, I'm using the interquartile range and this 1.5 in each of my quartiles. So to find your interquartile range, you need to find the difference between quartile 3 and quartile 1. Okay, so with that, I'm going to take quartile 3, subtract quartile 1. So that's your difference, that's your interquartile range. Well, quartile 3 is 7, and quartile 1 was 5. So my interquartile range is 2. Now I did write out how to find your outliers here. We're going to use these two formulas. Okay, so for the first one, I need quartile 1 minus 1.5 times the interquartile range. Now quartile 1 was 5 minus 1.5, and my interquartile range is 2. So I get 5 minus 1.5 times 2. I end up with 2. Okay, so that's for your lower half. Next I need my upper one, so I'm going to take quartile 3 plus 1.5 times the interquartile range. Quartile 3 was 7, and the interquartile range is still 2. So I have 7 plus 1.5 times 2. That's 10. Okay, so when I look at these, I'm trying to find the outlier. So do I have a number that's less than 2 in my data set?
No.
No. Okay, so there's not an outlier on the lower half. But if I look at my upper half, do I have a value that's greater than 10? Yes, I have 1. That's 12. Okay, so your outlier is 12. Okay, so you can have more than one outlier. You could have 2 in your lower and none in your upper. You could have 2 in your upper and none in the lower. Or you could have 1 at each end. Okay, so you do want to use these 2 formulas here to find the value and then see if there's anything lower than that value or higher than that value. Questions on that part? Calm down. All right, then I'm going to flip to the back here. Okay, the last part we want to do is find the mean, median, and mode, the range, and the standard deviation of the data set with and without the outliers. Okay, and then we want to compare each one. So with your outlier, you're going to find the mean, median, mode, range, and standard deviation. So finding our mean, that's your x bar value. That's where we add everything up and divide by how many there are. So if I look at the front again here, you're going to take all of these, you're going to add them together and divide by 26, since there's 26 values.
I'm gonna say 200 and...
Oh, yeah.
Say 14.
Sure. I'm gonna say 164.
So we remember how to find the mean, right?
Yeah, 160.
Yeah, the numbers.
It's 6.04.
Divide by how many there are.
Yeah. Add the numbers, divide by how many there are.
You get 6.
Your mean is 6.04.
Yeah, see?
What's our median? Yeah, which one is the middle one? It is 5.5. We found that one already.
Mode right now.
Mode is which one occurs most often. 5 is the value that occurs most often.
Good job.
The range, how do I find the range of my values?
Smallest and biggest.
Subtract. The biggest subtract the smallest. 2.
2.
That means it's 2.
Are you sure?
Means your range is 10.
Boy, you was close.
Did you actually write 2?
Okay, before I go into the standard deviation, we're going to do the same 4 without the outlier. That means we need to take 12 out of our data set.
Oh boy.
So you would find the mean of all of those values and you'd exclude 12, meaning then you'd divide by what?
12.
No.
5. 10.
How many
26.
values did you have?
26. I don't know.
A total of 26.
26.
So now if I take out 12, how many are there?
Take out 12.
14.
Yeah.
No, take out the value 12.
Oh. Then you have 25.
25. So add everything up, divide by 25.
What? What did you do?
Your mean is 5.8. If I,
She took out the 12. That's what we said in the beginning.
yes, you take out the
Take
12.
it away. Don't take 12 away.
Just
12
take
out.
number 12.
Just take it away.
Oh, at least you take out 12.
So if I take out my outlier here, this 12, what is my median? What's my median if I take out that term?
5.
It would be 5.
Oh. Right.
I know.
You right.
Okay, what's the mode without that outlier? It's still 5 because that's the one that occurs most often. Then what numbers do I take to find the range? 10 minus 2 is 8.
2.
All right, so standard deviation is what we did last week, Thursday and Friday.
Writing a bunch.
I didn't need to include all of these lines. I realized after I already created the table. So with the outlier means you're going to include 12. So my x values are 2, because I have a 2, right?
Yep.
Another value is 5. How many 5s did I say we had? 12.
What was it? Oh, yeah.
10 down?
12 down?
That's cheating.
I thought you said we only had to do 12.
So to here, those are all your 5s.
You did 11 down?
I counted this one. Okay, what's my next value that I have? In my data set? 6. How many 6s do we have? 5. So that ends here. Then I have 5 7s.
Whoa.
How many 6? 5?
5. And then I have an 8, a 10, and a 12. All right, so for my standard deviation, I need to take my x. There's 5 7s. I need to take my x, which is the number I wrote out here. And I need to subtract the mean. So I have 2 minus 6.04. Negative 4.04. Now what do I do with that number? Square it.
Turn into a square.
So you square negative 4.04,
Why can't it be a square?
16.3216.
We have to do that.
Huh?
Don't put that many numbers, maybe just 23.
I put that many numbers. Next, we're going to do the same thing with 5.
Negative 1.04.
You're cheating.
It is negative 1.04.
What is that?
Square that one. 1.0816.
Yeah, you did that in your class.
No, I did not do that in my
She's
head.
got it all pre-written down
What?
there. She's a cheater. She's copying. Yeah,
You're
freaking
cheating.
copier.
Can I
You
do
still,
that?
I can't hear you because they're talking. All right, since all of these are 5, all of these values are going to be 1.0816. So I don't need to redo it all again.
Oh my gosh.
Okay? So I'm just going to move on to 6 then. So I need to take 6 minus 6.04. It is negative 0.04. Okay, I need to square that. I get 0.0016. This is why you need to write out the whole decimal. Okay, all of these ones are 0.0016. So I can move on to 7. So I take 7 minus my mean, which is 6.04. Get 0.96. And I can square that value. Again, all of these values here are going to be the same. So I can move on to 8. So I have 8 minus 6.04. Yep, in my head. So I have 1.96, and I'm going to square that value.
I don't know why they put it in this class. Definitely smart.
To get 3.8416. We'll do the same thing with 10. So take 10 minus 6.04. Square that value. Yep. Last one is 12, so 12 minus 6.04 is 5.96. Square that. You get 35.5216. Okay, so now when you find the sum, I can't just add one of these, I need to add 5 of these. Okay, so you can go through and add them all, or once you get to this one, so once you have 16.3216 plus 1.0816, multiply that term by 12, since there are 12 of them. Then add 0.0016, multiply that one by 5, since there are 5. Then add on 0.9216, multiply that one by 5. Then add on your last 3. On your quiz, I think your problem has 7 values or 5 values. Do you want this many values? I can change it.
Yeah.
I can add some more.
Deal. You won't.
Guys. Eric, shut up. I want to hear your opinions.
Okay, when I added them, I got 88.9616. Huh? Okay, so then to find the variance, which is your s squared value, you need to take your sum of 88.9616, divide. There were 26 values, and I'm going to subtract 1. This is a sample.
Good question.
Yep.
Don't you have to multiply like all the 5s and stuff in there then too? Or is that without everything multiplied in? Okay.
What are you talking about?
So like you have 12 5s, is that with all the 1.0?
Yes, so this sum is with all of them. I put 3.558. Okay, so your variance is 3.558. How do I find the standard deviation then?
464.
Take the square root of that value. So it shouldn't go up.
No, you didn't say a full number. It was 3.558464.
Oh. So the square root of that value is 1.89.
Good job, team. Yeah.
So my standard deviation then, sorry, I'll wait, is 1.89, and I can write that with the outlier in that chart up above. So under with outlier, this is 1.89. I don't think the homework is this long. Okay, so now you're going to do the same thing. No, there's not that many values. No, there's not. We're going to do the same thing without the outliers, or the one outlier. So all of our numbers, except we're going to get rid of 12. Okay? So I still have...
So just do 88 minus 35.
No,
Why?
because your mean's different.
Well, that doesn't matter.
It does matter because you have to subtract your mean. So I have a 2. I have 12 5s. So that goes to here. I have 5 6s. 5 7s. An 8 and a 10.
How come this is not lined up right?
Because it's not lined up the same. I couldn't make it lined up the same.
Why?
Next time I won't give you a table to help you figure it out.
Thank you. Eric, that'd be great.
Okay, so
I don't know, this guy's.
with this one, since it's without the outlier, you're going to take your x, in this case is 2, you're going to subtract your mean, which we found to be 5.8 without the outlier. So you're not subtracting 6.04 this time, you're subtracting 5.8. Okay, so we have 2 minus 5.8. I did that right? Yeah. 2 minus, yeah. Okay, then I just need to square this value. It's 14.44. Move on to 5, so we're taking 5 minus 5.8. That's negative 0.8. Square that value. 0.64. And that's true for all of them up until this point. So I can move on to 6 here. So I have 6 minus 5.8. That's 0.2. When I square that value, I get 0.04. It's true for all of these. Next we have 7, so I take 7 minus 5.8 to get 1.2. Can you do that in your head? What's 12 squared?
144.
Right, so it should be 1.44. Next, move on to 8 here. So 8 minus 5.8 is 2.2. Square 2.2. That's 4.84. Then 10 minus 5.8 is 4.2. 4.2 squared is 17.64. Okay, and again, I want you to add these up. So you have 14.44 plus 0.64 times 12 plus 0.04 times 5 plus 1.44 times 5 plus 4.84 plus 17.64. Okay, so that's how you can enter it into your calculator. Otherwise, you can add 0.64 12 times if you really want to. You can do that. I'm not going to do that. I already have my sum. I got 52 as my sum. Okay, so then for my variance, I need to take my sum of 52. Okay, my n value. How many values did I have in this one?
25.
25. So I'm going to take 25, subtract 1. So I got to divide by 24.
So you got 2.7.
You are correct. 2.17. And we just have to take the square root. I get 1.47. And I can write that in my chart then.
Done.
At the top. Nah, there's a letter E on the side. You're not done yet.
You can get crossed out. I'm done with this.
All you have to do is describe the effect with taking out the outlier. Okay? So if I look at the mean, median, mode, range, and standard deviation, all of them changed except for the mode. Okay? So I'd say the mean, median, range, and standard deviation are affected
I just wrote all the data changes that we know.
by the removal of the outlier. Okay. The removal causes all four measures to decrease. Okay, so those ones are affected. Tell me how they're affected. They all decreased from when it was with the outlier. That's all it is.
Oh, that's all.
That's all.
That's all it is. Don't worry. It's one problem just like we did. And there's less numbers to it.
That's a hell of a lot.
16 instead of 26. 10 less.
You want to remember what talk to each other and watch your mouth.
Yeah, I got one because you have it.
Oh, okay.
I'll bring it tomorrow.
Yep.
You believe me?
I mean, I believe you. You're not going to talk to me on my watch, though.
Why not?